Achtung, Zündung in einer Minute. Die Druckwerte sind stabil. Freigabe erteilt. Freigabe erteilt.
In a dark room. Images taken not by a spy on the ground, but by a camera orbiting 200 kilometers above the Earth. At the same moment, in a windowless room in Washington, American analysts pored over nearly identical photographs, stolen from the sky by their own secret satellite. Neither side spoke of these programs publicly. Neither side admitted they existed. Yet high above the clouds, where treaties had not yet been written and no flag could be planted, two superpowers were already fighting a war that the world would not learn about for decades. A war fought with cameras instead of guns, with orbits instead of front lines, and with weapons designed to kill from a distance so vast that the target would never see them coming. This is the story of how the heavens became a battlefield, how the conquest of space was never really about exploration at all, and how the closest the Cold War ever came to a shooting war took place not on Earth, but in the silent dark above it. Space, in the popular imagination, has always been sold as a triumph of human curiosity, a story of astronauts, moon landings, and the peaceful expansion of a species beyond its home planet. That story is not false, but it is incomplete. Behind every rocket that carried a human being into orbit, there was another program, rarely photographed and never celebrated, whose purpose was not discovery but domination. The space race and the arms race were never separate contests. They were the same contest, waged on two visible fronts and one invisible one. The invisible front began before Sputnik ever left the ground. In the ruins of the Second World War, American and Soviet intelligence services raced not to defeat each other's rockets, but to capture them. German engineers who had built the V-2 ballistic missile, the world's first long-range rocket weapon, one that killed thousands of civilians in London and Antwerp during the war's final year, became the most valuable prisoners of the emerging Cold War. The United States quietly relocated over 100 German rocket scientists to Texas and Alabama under a classified program that stripped their Nazi Party affiliations from the official record. The Soviet Union captured its own share of German engineers and hardware, transporting them east to design bureaus hidden behind barbed wire. Both nations understood something the public did not yet grasp. A rocket capable of lifting a satellite into orbit was, with only minor modification, a rocket capable of delivering a nuclear warhead across an ocean. The conquest of space and the delivery of atomic weapons were, from the very beginning, the same engineering problem wearing two different uniforms. When the Soviet Union launched Sputnik in October of 1957, the West reacted with a mixture of scientific admiration and raw fear. The satellite itself was almost primitive, a polished aluminum sphere transmitting a simple radio beep, but its meaning was unmistakable. If a Soviet rocket could place an object in orbit above the United States, it could just as easily place a warhead there. American strategists did not see a scientific milestone. They saw the sky, for the first time in history, become a domain that an adversary could reach and the United States could not yet defend. The psychological shock of Sputnik reshaped American science policy, education funding, and military doctrine almost overnight, but its quieter consequence was to accelerate a shadow program that had already been taking shape in secret. The development of reconnaissance satellites designed to look down on the Soviet Union from the one vantage point no border guard could stop. That program, codenamed Corona, would become one of the most closely guarded secrets of the entire Cold War, hidden for over 3 decades behind a cover story about a civilian space research initiative called Discoverer. Corona satellites carried film cameras into orbit, photographed Soviet territory, and then ejected the exposed film in a small capsule that parachuted back toward Earth, where it was caught in midair by specially modified aircraft trailing hooks and nets over the Pacific Ocean. The early failures were catastrophic and repeated. Rockets exploding on the pad, capsules burning up on re-entry, film canisters lost at sea or recovered by the wrong nation entirely. But by 1960, Corona succeeded, and for the first time American analysts could count Soviet bombers on runways, missile silos under construction, and submarine pins along the Arctic coast, all without a single spy crossing a single border. Corona photographs revealed something that reshaped American nuclear strategy: the missile gap, a supposed Soviet lead in intercontinental missiles that American politicians had used to justify a massive weapons buildup, did not actually exist. The satellites had, in effect, prevented one arms race, even as they quieted and fueled another. The Soviet Union built its mirror image almost simultaneously. The Zenit reconnaissance satellites, disguised publicly under the Peaceful Cosmos designation, performed the same function as Corona, photographing American missile fields, air bases, and naval installations from orbit, then returning film capsules to Soviet soil. Both superpowers now possessed what amounted to permanent eyes in the sky, and both understood that whichever nation could deny the other that vision would gain an overwhelming strategic advantage. This realization gave birth to the deadliest ambition of the secret space war, the anti-satellite weapon. The Soviet Union moved first and moved seriously. Beginning in the mid-1960s, Soviet military engineers developed a co-orbital anti-satellite system, a killer satellite designed to be launched into an orbit that would gradually approach an enemy target, then detonate a shrapnel warhead close enough to destroy it. The program underwent dozens of tests through the 1960s and 1970s, refining an ability that by the end of the decade was considered operational: the capacity to destroy an American satellite in orbit within a single pass. American intelligence watched these tests with genuine alarm. Reconnaissance and early warning satellites were not luxuries. They were the nervous system of nuclear deterrence, the eyes that would give a president perhaps 20 minutes of warning before an incoming missile strike. A demonstrated ability to blind those eyes threatened to destabilize the entire balance of terror that had, however uneasily, kept the Cold War cold. The United States pursued its own anti-satellite ambitions along a parallel, if less publicized, track. Early American ASAT concepts in the late 1950s and early 1960s involved nuclear-tipped interceptor missiles, including a program that detonated an actual nuclear warhead in the upper atmosphere during a 1962 test, an event that inadvertently damaged several satellites, including some of America's own, through the resulting radiation belt, a stark demonstration of how indiscriminate space weapons could be. By the late 1970s and into the 1980s, American efforts shifted toward more precise, non-nuclear solutions, culminating in a program that launched a missile from an F-15 fighter jet at high altitude to strike a satellite directly with kinetic force alone. No explosive warhead required, simply the violence of a collision at orbital velocities. In 1985, that program succeeded, destroying an aging American research satellite in a test that proved the concept beyond doubt and left a debris field that would linger in orbit for years. Parallel to these weapons programs, both superpowers pursued something even more ambitious: military space stations, crewed outposts whose ostensible purpose was scientific research, but whose true mission, in at least one case, was overt military reconnaissance and, according to some later disclosures, self-defense against enemy interception. The Soviet Almaz program, publicly folded into the civilian Salyut space station series to obscure its purpose, placed military cosmonauts aboard stations equipped with high-resolution cameras for photographing NATO installations, and, remarkably, at least one station was equipped with an actual automatic cannon, adapted from an aircraft weapon. tested by remote firing after the station was unoccupied and preparing for deorbit to defend against the hypothetical threat of American interception or boarding. The United States developed its own answer in the Manned Orbiting Laboratory, a program that would have placed Air Force astronauts in a small station attached to a Gemini capsule, primarily for high-resolution photographic reconnaissance using a telescope camera system so classified that even the astronauts selected for the program did not initially know its full capability. Rising costs, improving unmanned satellite technology, and the sheer expense of maintaining a crude military presence in orbit eventually killed the American program before a single crew reached orbit, though the astronauts trained for it were quietly transferred into NASA, several of whom would go on to fly space shuttle missions in the following decade. The most ambitious and most publicly contentious chapter of the secret space war arrived in March of 1983, when President Ronald Reagan announced the Strategic Defense Initiative, a proposal to develop a space-based shield capable of intercepting Soviet nuclear missiles before they could strike American targets. The program envisioned orbital platforms equipped with lasers, particle beams, and kinetic interceptors, a technological ambition so vast that critics both American and international mocked it with the nickname Star Wars, borrowed from the popular film franchise. Whether the technology described in Reagan's speech was ever truly achievable with 1980s engineering remains a matter of genuine historical debate. Many of the specific weapons systems proposed existed only as early research concepts, and some scientists at the time argued the program was scientifically premature, if not outright infeasible on the proposed timeline. What is not in dispute is the psychological and strategic impact. Soviet leadership took the program with tremendous seriousness, fearing that even a partially successful shield could neutralize the deterrent value of the Soviet nuclear arsenal and tip the strategic balance decisively toward the United States. Some historians argue that the enormous cost of attempting to match or counter this program contributed meaningfully to the economic strain that helped precipitate the Soviet Union's collapse at the end of the decade, though this remains a debated point among Cold War historians rather than an established consensus, with other scholars pointing to deeper structural economic failures within the Soviet system as the primary driver. Throughout these decades, the secret war in space produced moments that came remarkably close to open conflict without either side firing what the public would recognize as a shot. Soviet ASAT tests in the 1970s prompted genuine American concern that a real conflict could open with the sudden, silent destruction of early warning satellites, an act that might be interpreted as the opening move of a nuclear-first strike rather than a mere show of force, given how difficult it would be to distinguish an ASAT attack from preparation for a broader assault. This ambiguity, the impossibility of knowing an adversary's true intent when their weapon is a slow-approaching object in orbit rather than a visible army crossing a border, made the space arms race in some respects more dangerous than its terrestrial counterpart, precisely because it was so poorly understood by the publics and even by many policymakers of both nations. Diplomatic efforts to restrain this hidden conflict moved slowly and incompletely. The Outer Space Treaty of 1967 prohibited the placement of nuclear weapons in orbit and forbade claims of national sovereignty over celestial bodies, a genuine and lasting achievement of Cold War diplomacy. But it left conventional anti-satellite weapons, reconnaissance programs, and space-based conventional defense systems almost entirely unaddressed. Later attempts at a dedicated ASAT treaty between the United States and Soviet Union, pursued intermittently through the late 1970s, ultimately collapsed amid mutual distrust and the invasion of Afghanistan, which froze broader arms control diplomacy for years. The result was that the most dangerous weapons of the secret space war were never formally banned, They were simply, gradually, allowed to lapse in active testing as both superpowers' economic and political priorities shifted, and as reconnaissance satellites proved themselves more valuable as tools of stability, allowing each side to verify the other's arms reductions than as targets to be destroyed. By the time the Soviet Union dissolved in 1991, the secret war in space had produced no casualties in the way conventional wars are measured, and yet its consequences were immense. Reconnaissance satellites had, paradoxically, become instruments of peace as much as instruments of espionage, allowing each superpower to verify arms control agreements without demanding physical inspections that neither government would have tolerated. The anti-satellite weapons developed by both sides were tested but never used in anger, remaining a threat that shaped strategic thinking without ever crossing into open destruction. The Strategic Defense Initiative was scaled back, redirected, and eventually folded into more modest missile defense research that continues in different forms today. Yet the debris of this era did not simply vanish. Fragments from Cold War-era anti-satellite tests remain in orbit even now, tiny pieces of shrapnel traveling at thousands of kilometers per hour, a literal physical legacy of a war that was never declared. The story of the secret war in space is, in the end, a story about how the frontier of human exploration and the frontier of human conflict have never truly been separate. The same rockets that carried Yuri Gagarin and Neil Armstrong toward the stars were direct descendants of weapons designed to end civilizations. The same satellites that predicted hurricanes and enabled global telecommunication began their lives as the deniable eyes of intelligence agencies. And the same orbital space that today carries commercial internet constellations and international research stations has, in the 21st century, become host once again to active anti-satellite testing by multiple nations, a reminder that the war that began in secret during the Cold War never truly ended. It simply went quiet, waiting in the dark above us for the next chapter to begin.